Welcome to the unit on Understanding Space and Form. This unit deals with application of the understanding from previous chapter of the elements and principles of design in visual merchandising. It also explains the transformation of space through application of these theories. By the end of this unit, students will be able to apply the knowledge of basics of design to space using forms to visualize space and its look. The first module reviews the different types of forms. So to recap, we did point a series of points make a line, a series of lines make a shape, and when you give a third dimension to the shape is when you get a form. So if our series of lines which make a shape like this, the third dimension to it would be like this. So this is the form. To this form you would apply texture and color, and that's how the form would get completed. We will also be doing about shapes, which where this is a shape until it is given the third dimension. The shape could be geometric. What we have over here is a geometric shape, or this is a geometric shape, and the other is an organic shape. So as we had discussed yesterday, a free-flowing shape is an organic shape. A geometric shape like this would become a 3D shape in this form. Similarly to an organic shape, if we add the third dimension to it, it would be something like this, where a third dimension gets added to it to make it into a 3D. Geometric and organic or free-flowing solutions for window or facade given by students in the class for the brands studied by them. The first one for Tommy Hilfiger is a very geometrical solution, and the second one for Pramod is a free-flowing solution. If one tries to understand the brand, one can see that both these solutions, geometric and organic, very well represent the brand and femininity. Coming to the next type of lines, the diagonal lines talk of action, forceful, strong and dynamic. For example, active sportswear mannequin often has all angles. The angles could be in the arms, akimbo, knees could be bent, head could be thrust back, and shoulders could be shrugging. A series of lines makes a shape. So the first was a series of points make a line. Now a series of lines make a shape. The smallest could be a triangle, it could be a hexagon or an octagon, and so forth. There are different types of shape, such as mechanical shape and organic shape. Mechanical shapes are geometric. So you can see here that this is asymmetrical, where you have the left different from the right. The window shown in this example is symmetrical, but the designs on both the windows are asymmetrical. The next aspect is positive and negative. When we talk about space design, the useful space or the design space is a positive space, but 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 so the suppose this was our central space, and through this space we had blocks which were getting connected in a circular fashion. Then if this was our entrance to the building, this would be the corridor which is parallelly connecting block 1 to block 2 to block 3. Then these spaces are our positive spaces, and these spaces are our negative spaces. So it is important in a planning stage to understand how the positive space and the negative space respond. If we had a plan which was like this, probably this which is a negative space would have become a positive space, as all the spillover activities would have happened here. But in this case, these negative spaces would go as waste, as there would be no activity that would happen in those spaces. You can see them through few examples. Here you can see that the negatives have been made as a positive by utilizing them as a backdrop mural for the window. So in this you see that whatever element has been taken out from the window has been used as a backdrop mural in the window. Positive and negative space, the space which is active and is used for productivity is a positive space. In retail, the merchandise display space is the positive space. The space left over as a resultant space is the negative space, that is the movement space. In planning, it is important to plan the layout in such a way that the resultant space or the negative space also becomes a positive space. It can become the launch area or a focal point of display area. The other aspect is overlapping. It is a rare phenomena that would happen as the spaces in retail store are planned and designed with utmost care. For example, overlapping of selling space with merchandise display space can create confusion at the billing counter. Say for example, if this is my store and this is my entrance and I have my counters in these areas. Suppose I put my billing counter here thinking that it is closer to all the counter areas, but this would create a confusion because the billing counter would be on the way of the people or the traffic that would be moving inside the store. Now we move on to learn about space visualizations. This can be learnt through an understanding of technical drawings which aid the visual communication. The first of them is orthographic views. Orthographic views are two-dimensional drawings used to represent or describe a three-dimensional object. The orthographic views represent the exact shape of an object seen from one side at a time as you are looking perpendicular to it without showing any depth to the object. Primarily, there are three orthographic views. One is the top view, seen from the top, also called as plan. The front view, seen from the front, also called as elevation. And the side view, seen from the left side or the right side elevation. Let us understand the orthographic projection for this duster. So as mentioned, the top view, the front view and the side views. So let us draw it. This is our top view. This is how it looks from the top. So let's take the outer rectangle. So this is our outer rectangle. Then we have an inner rectangle with a curve at the edge. So this is how our top view of this duster looks. This is our top view or plan. Now to draw the front elevation of it, take the projections up. Considering this to be the ground line, whatever is the height, this is our height. So whatever is this height, this is our first height of the base, and this both are at the same level. So let's consider this is our height and this is our front piece. So we see our front piece and that's a back piece. Now when you are rendering something that is circular, you render these lines closer, and as it comes closer to you, it becomes thicker. So the rendering would be like this. So this makes you understand that the figure is going inside and to the back. So this is our front view. Coming to the side view, this side or this side. So let's take, looking from this side, we're seeing this side view. So you draw a 45-degree line, take the projections from here onto the line, all the projections that are there, take the projections up, and the horizontal projections, or rather the vertical projections, would come from this side to give you the heights. Now the base, when we are looking at this side, the base is this. Now if you see that this edge is merged here, but the forward portion is this edge, so it's here, and applying the same rule here also, since this goes backward, the rendering would be closer to far. So this is how our side elevation would look like. Perspectives. This is the second part of it. First we did orthographic, now we will do perspectives. The difference between orthographic and perspective is that orthographic is a two-dimensional projection. Perspective is as a human eye perceives. Perspective is an approximate representation on a flat surface of an image as it is seen by the eye. The two most characteristic features of perspective are that objects are drawn either smaller or foreshortened. So to understand what is smaller and what is foreshortened, smaller as their distance from the observer increases, they get smaller. Foreshortened, the size of an object's dimension along the line of the sight are relatively shorter than dimensions across the line of sight. There are primarily two types of perspectives, 1-point perspective and 2-point perspective. Coming to the first one, 1-point perspective. A drawing has a 1-point perspective when it contains only one vanishing point on the horizon line. This is the most preferred in interior views. What the camera captures is a 1-point perspective. Now let us see how a 1-point perspective is made. So let us say this is our room. Height of a human being, we consider it to be 1.5 meters. So this height from our ground floor is generally 1.5 meters. Then we divide this frame into equal parts. The same way divide the vertical plane also into equal parts. Basically this dimension is the length of the room and this dimension is the height of the room. So now that we have got our viewing point and we have divided the length of a room and the height of a room into equal parts, let us join the lines from this point and project them. Now draw a 45-degree line from here, and wherever it cuts these projected lines, draw a horizontal or a parallel line to your ground line. And as you can see, it's forming a perspective. What is closer to you is bigger, and as it goes farther away from you, it becomes shorter. Now let's take the projections of these vertical. And suppose we had a table which was placed in this grid and was a height, the height of the table was, say, this. Then you have to draw a parallel line from here, draw a parallel line from here, take the projection up from here, take the projection up from here. So this is the front of our table, this projection is the back of our table. So that is our table in 1-point perspective. The next is a 2-point perspective. A drawing has 2-point perspective when it contains two vanishing points on the horizon line, that is the eye at which, the level or the line at which we are seeing. In an illustration, these vanishing points can be placed arbitrarily along the horizon. 1-point perspectives give the front view of the building, whereas 2-point perspectives gives the side view of the building. If 1 point is good for overall interiors, a 2-point may explain the individual furniture in detail and in a much better way. So let us try to understand the 2-point perspective. They could be aerial, that is when you look from top. If this is my object, when I try to see from here, this is my aerial view. When I see it at my eye level, this is my normal view, and when I see it like this, which is the bird's eye view, that is, I am seeing the object from the bottom. So let us understand how a two-point perspective is done. So this is your horizon line on which your eye is going to be. Let's take the two vanishing points and we take the center point. First one is an aerial view when I am seeing from the top. So this is my top level, and suppose this is the height of my box. So that's the height, and this is the vanishing. Suppose this was the length of my box and this was the width of my box, then this point would get vanished here and this point would get vanished here. So this is my aerial perspective. If the same box was at eye level, then the box would be half up and half down placed. So my box would be taking the same vanishing points, would be like this, and if this is the height, so I would get the box in this manner. Now let us consider the bird's eye view, that is, I am seeing the box when I am like the worm's eye view when I am bottom and I am seeing the box above me. So my box would be above and this is the eye from where I am watching it. So it would be this way. And these points would get vanished to this point would get vanished to this. So this is my box 1, box 2 and my box 3. This is bird's eye view. This is normal eye view and this is worm's eye view. So it's like a worm and you're seeing it from the bottom of it. Next, let's talk about vertical linear elements. So if you have a plane, there are 4 columns or pillars which are coming on the 4 edges of it. So these are your vertical linear elements. As shown in the image, vertical linear elements define the perpendicular edges of a volume of space. Next, let's talk about single vertical plane. A single vertical plane articulates the space on which it fronts. That is, you have a plane and you have one vertical frame which defines the edges of that horizontal plane. Next is an L-shaped plane. So in the single vertical plane, you have only one edge. In the L-shaped, you would have 2 edges out there. An L-shaped configuration of vertical planes generates a field of space from its corner outward along a diagonal axis, as you can see in the image. The next is a parallel plane. That means same base, we have 2 planes on the parallel edges. 2 parallel vertical planes define a volume of a space between them that is oriented axially towards both open ends of the configuration. Next is a U-shaped plane. As the name indicates, it will be in a form of a U. A U-shaped configuration of vertical plane defines a volume of space that is oriented primarily towards the open end of the configuration. So here you can see this is the plane and you have on as a U, that is 3 sides are covered by planes. Next is the four planes closure. So, as the name indicates, it obviously will be enclosed on all four sides. Four vertical planes establish the boundaries of an introverted space and influence the field of space around the enclosure. So, it could be like a bin have come to the end of this unit. To summarize, there are two types of form and structure development: geometric and organic. Space visualization can be done through orthographic representation or through perspectives. Orthographic projections are technical drawings with accurate dimensions. Perspectives are inaccurate and help the layman in visualizing the end product. A couple of images have been shown to explain how a finished product or the finished window would look like. The complete design process can be seen through this slideshow. Thank you.